Welcome to our lesson today. We are looking at Chemistry, Paper 2, 2022, Question 1. Question 1, we have Part A and Part B. Part A was testing structure and bonding. Then Part B was testing the knowledge of the periodic table. In Question 1A, aluminium and phosphorus forms oxides with a general formula M2O3. Complete table 1 by writing the properties of the oxide. So we have a property, we have aluminium oxide, we have phosphorus oxide. We have a structure of aluminium oxide, a structure of phosphorus oxide, bonding between aluminium oxide and phosphorus oxide, then acidic or basic character. We have the compounds of nonmetals in structure and bonding, and then we have compounds of metal in structure and bonding. What you need to understand first that all metals have a giant metallic structure with strong metallic bonds. So first of all, we can say that all metals have giant metallic. All metals have a giant metallic structures with strong metallic bonds. With strong metallic bonds. All compounds of metals have a giant ionic structure. Another point, all compounds of metals have giant ionic structure. With strong ionic bond. So you have them, this one with strong ionic bond. Except aluminium, aluminium chloride. Except aluminium chloride. So except aluminium chloride, this one has a simple molecular structure. So this has a simple molecular structure. So the aluminium oxide, all compounds of metals have a giant ionic structure with strong ionic bond. So this one has giant ionic structure. With strong ionic bonds. All nonmetals and their compounds have simple molecular structure. So all nonmetals and their compounds have a simple molecular structure. Of a molecular structure, and all of them they have weak van der Waals. So they have weak van Waals forces. So all nanometals and their compounds have a simple molecular structure with weak van der Waals forces. So our phosphorus oxide, this one here, it has a simple molecular structure. So we have this one has simple molecular structure. It has a simple molecular structure with a weak van der Waals forces. With weak van der Waals forces. So the all nanometals and their compounds have a simple molecular structure, but we have some nanometals which do not have a simple molecular structure, likes of silicon and silicon dioxide. So we have a silicon and a silicon dioxide. Silicon and silicon dioxide. This one have a giant covalent structure. So this one have giant covalent structure. They have a giant covalent structure with strong covalent bonds. With strong covalent bonds. So that is this is what you needed to know before you answer that question. So we have aluminum oxide. It has a giant ionic structure. So this one we can have a giant ionic. So they have a giant ionic structure. All compounds of aluminum except aluminum chloride, they have a giant ionic structure. Phosphorus, all nanometals, they have a simple molecular structure except silicon and silicon dioxide. So this one we have simple molecular. We have this one as simple molecular structure. Now in bonding, we have aluminum oxide. It has ionic bond. So this is the ionic bonding. On the other side, all the compounds of nanometals, they have a covalent bond. So we have this one as covalent bond. In this one, acidic and basic character, the aluminum oxide exists as an amphoteric oxide. So we can complete this one as amphoteric. We have this one as amphoteric. That means it has the acidic and the basic property. Whereas the phosphorus or the phosphorus nanometals, they are acidic compounds. So this one here, it is acidic, correct? Let us look at question P. The grid in figure 1 shows part of the periodic table. Use it to answer the question that follows. You can see this periodic table is plain. It is not filled anywhere. It is just plain. You are supposed to give the total number of elements that can be placed in period 1, the total number of elements that can be placed in period 5. When we count or vertical, we have 1, 2, 3, 4, 5. This one represents the period. So when you are counting vertically, we can have the period, and then the horizontal represents the group. So we have group 1, group 2, 3, 4, 5, 6, 7. Period 1, 2, 3, 4, 5. So you can have periods. You have period 1, period 2, period 3, period 4, period 5. We have group 1, group 2, group 3, group 4, group 5, group 6, group 7, and then we have group 8. Now, the total number of elements that can be placed in period 1. We have period 1. How many elements can be placed there? We have 1, 2. So we have 2 elements that can be placed in period 1. In period 5, we have period 5. So the total number of elements placed there, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So we have a total of 18 elements which can be placed in period 5. Place each of the following elements in the grid. We have element X whose atomic number is 14. Element X atomic number is 14. You write the first of all electronic configuration. This is 2.8.4. You can get this one in a group. You get group 4. When you are checking an element in a group, position of a group in the periodic table, you look at the number of electrons in the outermost energy level. So this one has 4, meaning we can get this element in group 4. How many period? It occupies how many energy levels? 1, 2, 3. The number of energy level occupied gives the position of a period of that element on the periodic table. So you have period 1, 2, 3, group 4. So you go to period 3, 1, 2, 3. Then you go to group 4, 1, 2, 3, 4. So you place that element X there. Element Y with the highest ionization energy. Element Y with the highest ionization energy, across the period, the ionization energy increases across the period. Down the group, the ionization energy decreases. So this element Y with the highest ionization energy, you aggregate it at group 8 at the top. Group 8 at the top, so you will have that element Y there. Element Z with the lowest ionization energy. Lowest ionization energy, you aggregate in lowest ionization energy, you get that element in group 1 at the bottom. So group 1 at the bottom, we can have that element Z. That is where you can have element Z. Element L goes ion L2 minus as an electronic arrangement of 2.8. This 2.8, it is the ionic configuration. The electronic configuration of this element is 2.6. Because it forms a negative, it means the element forms an ion by gaining the 2 electrons. So if it gains the 2 electrons, it can make an ionic configuration of 2.8. So the element is found in period 2, 1, 2, group 6. So we have period 2, then we go to group 6, period 2, group 5, 6. You will have element L there. We have element D whose ion D positive as an electron arrangement of 2.8.8.8. The electronic configuration of this one is 2.8.8.2. It is a positive here. It means it forms an ion by losing the 2 electrons. So you will get this element in period 1, 2, 3, 4. You get in period 4, group 2. So you can come period 4, group 2. That is where you have your element D. So you place that element there. We have element Q, halogen. So if it is an halogen, meaning that we found it in group 7. So we have group 1, 2, 3, 4, 5, 6, 7. So we can get that element on this group 7. So it is an element Q halogen with the highest atomic radius. So when we are in group 7, the atomic radius increases down the group. So if we have the atomic radius increases down the group, we have that element Q at the bottom of group 7. So the bottom of group 7, you will have element Q there. We have element R, period 3 element that exists as a monatomic gas. All of these monatomic gases, you will get them in group 8. So group 8 elements, all of the elements all of the element exist as monatomic gas. Monatomic gases. So you will get that it is in period 3. So you get at group 8. So group 8 is here, period 3, 1, 2, 3. So you will get that element R, which exists as monatomic gas. First, my journal, Marita James, Girls Boys High School. Then you will get more of periodic table questions, analysis, and how the questions are being set in KCSE. Please subscribe to my channel. Click the notification bell so that you will be notified once I upload a new video.